morning, guys. How are you?
Good.
How was your evening?
Good.
Okay, today is February the 13th. It is Wednesday, okay? Your objective today is kids students will be able to multiply using binomials for the FOIL method and the box method. So for the agenda, we're going to do our do now, then we're going to talk about the homework, and then we're going to do lessons 4, and if we have time, we'll do lessons 5 since we're a day behind, okay? So, as usual, I like to give you all an option. Do you want to do the do now together as a group, or do you want to do it independently?
Together.
Okay, so the first thing I need you to do is to take out lesson 3, okay? Lesson 3 is when we learn how to do FOIL. So please, let's reference our FOIL notes, okay? So, this is considered a binomial, right?
Yes.
And let's dissect the word binomial. Why do we call it a binomial? Bi means,
It's two and then numbers.
so yes, and nomial is numbers, so 2 numbers. So we're talking about 2 numbers or 2 terms within an expression. And does anybody remember the difference between an expression and an equation? Very good. The expression does not have an equal sign. So we just determined that this was a binomial. So that means we need to write it twice. Okay? And if we're looking at our notes on FOIL, what does FOIL mean? Could you say it louder, please?
First, outer, inner, last.
First, outer, inner, last. Okay? So, Mahogany, could you please identify what are our first terms in each expression? What is first? The X, but what is in front of the X?
4.
So say the whole thing.
4x.
Very good. So 4x to the second power. And what is my first in the next set?
4x.
Very good. 4x to the second power. Okay? So we have 4x squared times 4x squared. Okay? What is our outermost term, Zaria? What is on the outside when we're looking at both of our sets of parentheses? What do we see that is on the outermost part?
4.
Very good. The 4. And what else?
The 2.
That's a nice guess. Would you like to phone a friend?
Yeah.
Want to ask one of your group mates up here?
Rice.
All right. What is our outermost term? She identified the 4x, but what is our other outermost term? 5. Very good. So 4x squared times 5. Okay. What is our innermost terms? And this time, I want you to talk to your shoulder buddy. So Mahogany and Zaria, you talk to each other, and you 3 can talk to each other. Take about 30 seconds, and let's identify what are our innermost terms. And when someone has an answer, if you could just raise your hand. Yes. That's a nice guess. Do you all need help? So we're talking about our innermost terms. We're talking about the terms that are on the inside. So that would be 5 and 4x squared. So 5 times 4x squared. Okay? And what is our last terms? Meaning, what do we see last in both sets of expressions?
4x squared, 5.
That's a nice guess, but I'm saying, what is the last number that we see
5 and 5.
in both sets of expressions? It's 5 and 5, right? Alrighty. So, okay, if you do not have a calculator already, that's fine. I will come around and hand them to you. Okay. So, now what we need to do is if we look at lesson 1 from unit 6, lesson 1 is where we explain the rules of exponents. So we're going to look at the multiplication rule of exponents, right? So when we multiply, what is 4 times 4?
16.
16. So my question is, when we're multiplying, what happens to the exponents?
You add them.
You add them, right? So what are my two exponents here?
Well, it's 2, but it's gonna be 4.
Right, it's 2. So 2 plus 2 is 4, so we have x to the 4th. Very good. So now what is 4x squared times 5?
20x squared.
Very good. 20x squared. And what is 5 times 4x squared?
20x squared.
20x squared. And what is 5 times 5?
25.
Very good. So now we have to combine our like terms. Remember, when we're combining like terms, we look at the exponents and the variables to identify what's the same. So do I have any more x to the 4th?
No.
No, so I can go ahead and write that. Do I have any common x squareds?
Yes.
I do. And so what is the coefficient of those? Meaning, what is the number? 20, right? So what is 20 plus 20?
40.
40. So now I'm just going to write it horizontally. And do I have any more constants that are by themselves?
Yes.
25.
It's 25, right? But do I have any other ones?
No.
Nope. This is our final answer, okay? So this is what we learned yesterday, okay? I'm gonna actually save part B with you guys because this class period did not learn how to do that because you missed the lesson, okay? So this is a good segue into what we're gonna do today. So, next on our agenda was to review the homework, okay? Our homework, I was out yesterday, so Monday, you guys were supposed to finish all USA test prep and lesson 2 independent practice, okay? I'll check that at the end of the period, okay? Because remember, grades are due. Yes, George?
That USA test, but we gotta do that in the first period, and like yesterday.
Yes, that's what you all had to do in class yesterday when I wasn't here.
Okay.
We're gonna finish that for homework.
I have a question, like, do we have to do like all the time on that, or just like try to do as many as you can?
Try to do as many as you can. I just want to see the attempt because it helps you with the end course. That's just reinforcing things that we did last semester. Yes,
I'm not doing my login from.
I'm gonna give it to you at the end of class. I have it in the back.
Okay, thank you.
Okay, alrighty. So today we're gonna do Unit 6, Lesson 4, and Lesson 5. Okay. Alrighty. So please take out your interactive notebooks. Okay. And flip to your table of contents. Everyone have out their notebooks. Let me see everyone's table of contents. Okay. Where's your table of contents? There you go. Good job. Good job. Good job. You just started with us, so that's all you should have right now. Good job. Alrighty. So do you guys need me to zoom in so you can see?
Yes.
Alrighty. So today's lesson, okay, Unit 6, Lesson 4, which is multiplying binomials. Your objective is use the box method to multiply binomials. So let me zoom for you. Alrighty. So today is 2, 13, 19, Unit 6, Lesson 4, okay, multiplying binomials. Okay, put box. And make sure you put foil at the one above it. When you all finish writing, give me a thumbs up so I know I can move on. Thank you. So far, I received 1 thumbs up, but I don't see everyone. Oh, okey-dokey. Thank you guys. You guys are awesome. You ready, George? Alrighty. So far your notebook, okay, we did lesson 1, lesson 2, okay. Make sure you have your sheets glued in for your independent practice. We left off with some foiling, okay? Make sure you leave this page blank because on this page is where you're gonna have your lesson 3 independent practice, okay? So, we do Cornell style, come over 6 lines, 6 to 7, whatever you're most comfortable with. Draw your line, okay? Make sure you are writing your headings because we do have a notebook check and I will be looking for this. So, multiplying binomials. Always make sure you write your objective. Okay, since we're gonna try to do 4 and 5, this is 4. So using the box method to multiply binomials. And I think you guys are gonna like this much better than the FOIL method, okay? So we discussed what I'm about to ask you during the do now. So what do we say binomials mean? Two numbers, okay? What we're gonna say, for the sake of using expressions, we're gonna say 2 terms, okay? So 2x to the third plus 3x to the second, okay? Those are 2 terms, so that would be a binomial, okay? Can someone tell me something that is key in identifying terms? Take 30 seconds and talk to your shoulder partner about it. I'll give you a hint. Something separates them. You ready? You know? That's a nice guess. Look at how I wrote these. What separates them? Yes. What separates the 2 terms? What's in the middle of them? Right, so terms, okay, are separated by an operational sign. That's a little note to self. So when I say operational sign, I'm meaning addition, subtraction, multiplication, or division, okay? That makes sense, everyone? Alright, so let's get into these notes, okay? And the first thing we're gonna do is give in the steps, okay? We learned how to FOIL and how to multiply the polynomials previously. Right now I'm gonna give you the steps to be able to do the box method, okay? So the first thing that we wanna do is to label your column and your row in the binomial. Okay, let me know if I'm moving too fast, okay? Step 2, you're going to make or draw a box table and label the column and row with the corresponding terms. Am I going too fast or we good?
Yeah, just a little bit.
Okay, I slow down. I'm gonna pause for a second.
Yeah.
All right. Look up when you're finished. Alrighty. Step 3, you're going to multiply opposite sides of the box chart. table, shall I say. Step 4, combine like terms. Diagonally, okay? Can you all see?
Do it again a little bit.
Zoom in some more? Alright,
Right here.
see everything? Alrighty. So example 1, I'm just gonna draw my box.
That's a combine, combine like this.
Yes, ma'am, combine. Oh, yes. So as I am doing this problem, okay, before you guys write it, I just want you to watch me so you can get a full understanding, because if you're writing while I'm explaining, then you're not gonna understand it, okay? And so, how we're gonna do it, we're gonna walk you through example 1, we're gonna do another example together, and then I'm gonna give you all your independent practice assignment, okay? Everybody okay with that? All right, so you can put your pens and pencils down, and then I'll let you know when you can capture. I want you to focus on the actual material first, okay? It's okay, Mahogany, I'm gonna give you a chance. All righty, so it says step 1 to label your column and your row from the binomial, right? So I'm gonna always label my column first, and then my row, okay? If you want to, off to the side, not right now, when I'm finished, you know, C means column, R means row, okay? And we know the difference between a column and a row, right?
Yes, column.
Okay. So I'm gonna write X here, 4 here, 2X here, and -4 here, okay? Do we understand how I wrote it, okay? I did my column, my X and my 4, then my row I'm going down, 2X, -4, okay? So now what I'm gonna do, step 2 says make and draw the box and label them, that's what I just did. Step 3 says multiply opposite sides of the box chart or table. Meaning, what is X times 2X?
2X.
2X what? Because remember, when there's no exponent behind the variable, there's an imaginary what?
1.
Right, so I have 2 X's, so 1 plus 1 gives me,
2.
so it should be 2X to the what?
Second power.
Very good. Now, let's do 4 times 2X. 4 times 2X gives us what?
8.
8 what? 8X, very good. X times -4 gives us what? Very good. And Isaiah,
Yeah.
can you tell me what 4 times -4 is?
4 times -4 is 8.
That's a nice guess. If you don't know, you can use your calculator. Hmm?
-8.
No, I want you to use your calculator.
Oh, here you go. Here you go.
And 4 times -8.
No, 4 times -4.
-16.
Very good. -16. Now it says combine like terms diagonally. So in order to do that, what you do is start at each box and draw your line beyond the box, okay? This doesn't hit anything else, so I know I can't combine it with anything else. So now I come here, I draw from 8X through the -4X, okay? If you look, I cross through my 8 and my -4. They both have a variable of X that's by itself. Those are my like terms, okay? Then I draw a diagonal through my -16. It doesn't intersect with anything else, does it? Okay, don't write anything yet, I just want you guys to watch me, okay? So, this lets me know what my like terms and what to identify. Do you guys like this better than FOIL?
Yeah.
I definitely like this better than FOIL, okay? So now I'm gonna write things horizontally. So 2x squared, okay? I drew my diagonal through my 8x and my negative 4x, right? So what is 8x plus negative 4x? Or I can simply say, what is 8 minus 4? 4, okay? And I'm going to keep my x, okay? And then what happens to my constant? What do I need to do with that? Add it to the back of this, right?
Yes.
Right, and it was negative 16. So I can write plus negative 16, or I could just write minus 16. They both indicate the same thing. Not yet, okay? Let's do one more example together, and then I'm gonna pass around the independent practice, okay? Can someone give me a time check? What time is it? Thank you. Alrighty, so here's the problem. What does step 1, you can read it off of your notes, or you can read it off of my notes. What does step 1 say to do?
Label the row and label the column and row.
Right, so I write my C first, and then my R. George, what does step 2 say to do?
To make a box, table, and
Label.
label the columns, rows
With the corresponding
with the corresponding
term.
to
Very good, okay? So I'm gonna make my box table. Okay, what am I gonna write above the first one?
X.
What's in front of the X?
5x.
Thank you, 5x. What am I gonna write above this one?
3.
3. Zaria, what am I gonna write above next to this one?
2. No,
What's before the 2?
3.
3 what?
3 negative?
What's
No,
behind
positive
3?
3. Yeah, positive 3.
What's behind it?
Oh, X.
X, okay, we can't forget to leave those off. And Isaiah, what goes here? She did the 3x, so that, alright, very good. Okay, now let's start multiplying, okay? What is 5 times 3?
15.
And then x times x.
1.
Remember, when there's no exponent behind the variable, it's an imaginary one, and you have to add them. So x to the,
Second.
very good. What am I gonna multiply next, Raise?
3 and 3.
3 times 3 what?
X.
Right, so what is 3 times 3x?
9x.
Very good. Mahogany, what do I multiply next? Would you like to phone a friend? Okay. Let's look at the previous example, okay? We looked at the previous example. When we got to this slot, we multiplied the x and the negative 4, okay? So we multiply x and negative 4 here. What do we need to multiply here in those same spots?
X and 2.
What's in front of the x? You can't leave the coefficient off. Very good. So 5x and 2. So what is 5x times 2?
5x.
She said 10.
Okay, so 10, and then what about that variable? You can't leave the variable off. Good job. Isaiah, what do I multiply next?
You multiply 5 times. Wait. 3 times 3.
3 times what?
3 times 3x.
No, we did that already. That's a nice guess. Okay. We have to do what's next to the bottom box. 3 and what?
3 and 2.
3 and 2, right? So what's 3 times 2?
6.
6. What is my next step to do after I multiply opposite sides?
It's to multiply the opposite side.
Say it again, Mahogany.
Combine like terms.
Combine like terms diagonally, right? So I start at my top box. I draw my line. It doesn't intersect with anything else. I go through 2 points here, I go through 1 here, okay? So 15x squared. What 2 things that I have in common after 15x squared? We done with that, what's next?
9 and
9 and 10.
9x and 10x.
9x and 10x, so when we combine those 2 numbers together, what do we get?
10.
90.
Plus 19x. 19. Remember, when we combine them, we're adding, okay? So we're combining like terms we add, when we're multiplying the things that are on the outside of the box, okay? I can understand why you got that confused, and I'm glad that you pointed that out, okay? And so we've done that, and so what's the only thing that's left? 6. Okay. Very good, guys. So now, you guys may write and copy these notes, okay? So what I'm gonna do as you guys are copying the notes, I'm going to come around with your independent practice, okay? This is a picture of, I'm just gonna flash it really quick. This is a picture of the independent practice, okay? And I'm gonna come around and give it to you guys. So there are 25 problems on this independent practice sheet. However, you guys are only required to do 10. You can pick any 10, okay? Any 10. You can pick any 10, okay? Do not follow the directions that are on the sheet because I think they're too confusing, okay? So you have 2 options, okay? You can work in your collaborative pairs to do the 10, or I'm gonna put up chart paper, okay? And you can do it with your partner in a gallery walk. It is your option, it is whatever you choose.
I can look at the gallery walk.
You wanna do the gallery walk? Okay, so we're gonna do the gallery walk. Right now, I want you guys to finish writing your notes, and then when you finish writing your notes, we'll start the gallery walk, okay? All right, thank you guys.